All right, another tricky problem here. Now, again, I'm seeing a composite function. I have the square function, right? In the denominator here, I've got the square function with a polynomial inside of it. And the polynomial involves an x to the fourth, right? So derivative of x to the fourth is x is going to be, 4x cubed, and I see an x cubed up here. So let's try substitution. And I'm going to let w equal 2x plus 3x to the fourth. Okay, so that dw is equal to 2 plus 12x cubed, all right, times dx. And that derivative doesn't quite match what I have in the top, but if I divide it by 2, it will. So let's say 1/2 dw is equal to 1 plus 6x cubed dx. Okay, so now let's make that substitution. We get the integral of 1 over w squared, and then we're combining this and the dx, and that becomes 1/2 dw. All right, so we can just bring the 1/2 out front, and then I'll rewrite it here. 1/2 integral, I'm going to make this 1 over w squared into w to the minus 2 dw. And then I can use the reverse power rule. So I get 1/2, and then this is going to be w to the minus 2 plus 1, which is minus 1, over minus 1, okay, plus c. All right, and now let's go back to x. Let's resubstitute our w value. So I'm going to get minus 1/2, right, combining the 1/2 and the negative 1 in the denominator. And I get that's 2x plus 3x to the fourth to the minus 1 plus c. Now I could just leave it like that, or I could rewrite it a little bit differently. I could also write this as 1 over, because I've got 2 in the denominator, and then this is to the minus, this polynomial is to the minus 1 power, so I can move that to denominator 2 and then distribute the 2. So I'm going to have 4x plus 6x to the fourth, okay, plus c. So you could write it either way. Either way is fine.